Hi, I would like to take a few minutes to go through the answers to page 13 on the bridge activity. Now, keeping in mind that your answers can't be exactly like mine because you are doing the experiment on your own. In order to do the experiment, you click on this link right here. So the goal for page 13 is I can experiment to find a linear pattern. Your x, which is your independent variable, was the bridge thickness, and your y, dependent variable, is the number of pennies. If you would like for a bigger explanation of why that is, please watch the other video I made on the instructions on this page. Basically, it boils down to the number of pennies depends on the bridge thickness. So as you change that, the number of pennies will change. So looking at my data, when the thickness was 1, the pennies or the bridge broke at 6. When the thickness 6 pennies. When the bridge thickness was 2, it took 11 pennies to break it. At 3, it took 13. 4, it took 15, and 5, it took 18. And then I went to Desmos, and you can add table like this. And then I typed in the information. It plotted the points for me. I took a screenshot and I put it in this slide. And then to go through the questions at the bottom, is it a linear or nonlinear relationship, and how do they show this relationship? So it's not like perfectly linear, like it doesn't make a straight line, but since it asks about the relationship, or if it talked about association, it doesn't have to be perfectly straight. It just needs to, you need to be able to see that it's heading in a linear direction. So as the thickness increased, the number of pennies it took to break it did increase. And so that's going to show that it is a linear relationship. So what would you predict for 2.5 layers thick, and why? Well, when I look here at 2.5, I can either look 1, 2.5, and I can go up. Oh, wait. Sorry. It looks like every 2, so my scale is by 2s. So here's 2, and so it would be between this point and this point. So I'm going to say that that looks like it would be around 12. You could also look at the table, and your answer to this should be halfway between your 2 and your 3. So 2.5 would fall right here, and the halfway point here would be 12. So I would expect 2.5 layers thick to be 12. And then you can do the same thing with 6 layers. You're just going to go up here. So every time I'm seeing mine's increasing by 2 or 3 each time. So at 6, it would either be at 20 or 21. You could also kind of look at the graph here. And at 6, you would see that it would land about 20 or a little higher. So when I did my experiment, it did match. I got 20 pennies for a thickness of 6. So again, for 6 layers, I'd predict 20 or 21 because it would be 6 layers, because it seems to be increasing 2 or 3 at a time. And then yes, I got 6 at a 6 thickness. Whew, I got 20 pennies. So is it? How does it look like? What does a linear relationship look like in a graph? As the x increases, so does the y. What about a table? It's the same thing. As x increases, so will y, at a pretty consistent rate. And then where in life could you see linear relationships? The more hours you study for a test, the higher grade you could get on a test. So as the hours increase, so could your grade. Again, it's a relationship. It's not the hard and fast rule every time. But for the most part, the longer you study, the better your grade. So if you have any other questions, let me know.